four transactions, and how these events can affect each other. So consider a table which contains the customer ID and the balance for the customer. So let's focus on a single row there which contains the customer ID as 1234 and the balance is 1250, and assuming we have row level locking for this table. So this table is called cust_tab. So in the first transaction, that means the event 2, we set the isolation level to committed read. So at this point we know the customer 1234 has a balance of 1250. So event 3, we start transaction. At event 4, we issue an update statement in transaction 1 where we withdraw $400 from the account. At the same time, transaction 2, 3 and 4 start a new unit of work. Event 5, we have successfully withdrawn $400 but still not committed the transaction yet. The balance for the customer 1234 is 850. Again, the row is uncommitted. The event 6, we are taking this $400 that we withdrew from the customer 1234 and transferring that $400 to another customer whose ID is 3456. At the same instant, transaction 2, 3 and 4 will issue the same select statement to get the balance from the customer ID. The difference between transaction 2, 3, 4 is transaction 2 is committed has set the isolation level to committed read. Transaction 3 has set the isolation to dirty read. Transaction 4 has set the isolation to committed read last committed. That's the new isolation level in IDS version 11. So at the end of event 6, so in the transaction 1 we have updated the balance on customer ID 3456 and added $400 to customer's balance. In transaction 2, because we have committed read and because the row on the customer ID 1234 is locked, we still wait. In transaction 3, since it's dirty read, we don't wait, we return 850 because the row was locked but we were allowed to read dirty. In the transaction 4, the last committed means we want to know the value in this row. I mean, obviously if the row is not locked, we will get the value that's available. If the row happens to be locked, that means it's dirty, it's in the middle of the transaction, or it's in the process of being updated, so the row is locked and cannot read it. Sometimes even the dirty read has to wait a little bit before it can retrieve the value. In the transaction 4, if the row is locked, it will go to the log, it will go to the logical log and recreate the value that the row had before the transaction 1 changed that particular row, and then retrieve that value. In this case that happens to be 1250. And then in the event 7, while the transaction 2 waits for the lock, and the transaction 4 is free to continue with its rest of the processing. So you can see the difference between these three modes here. In committed read, you wait till you have a sane version of the value. In dirty read, you don't really care if it's been dirty. In transaction 4, you do get the value of the row when it was in a consistent state and go forward. So that's the difference. Let's look at the same example in a slightly visual manner. So this basically shows the session 1 is trying to withdraw from row 1, 2, 3, 4, whereas session 2 is trying to do a committed read on the same row, but it locks because it waits because the row is locked. Session 3 continues because it gets the dirty value of it, and session 4 will go and get the real value from the logical log, because it can read what changes that were made to the row within the current transaction that affected the row and recreate the old value. There is a typo in this slide. In the middle of the slide we say x3 : reconstruct. It should actually be s4 : reconstruct, because reconstruction happens only when you try to read it with the read committed, last committed isolation level. Okay, moving to next feature. So IDS version 11, and actually starting with the IDS version 10XE3 fixed bank, we have enabled direct interaction between IDS and WebSphere through a set of MQ functions. So these functions are simply they are simply named MQ send, MQ receive, MQ publish, subscribe, etc. to simply exchange data between IDS and WebSphere. The details of these functions are obviously in our manual and in the IDS version 11 red book, and we have a detailed article in developer works as well. So please look for that in those respective places. One additional thing in this feature is we have abstracted or exposed the WebSphere MQ queues as MQVTI table, so that when you select from this table, you actually read the data from the queue, and when you insert into this table, you actually send the data out to the queue. So this saves a lot of training, etc. for your application programmers, because they don't have to learn anything about WebSphere MQ. They treat the data in tables. They just select